Hello students, welcome you all on YourPedia. So my dear students, as you know, examiner of design and patent already start their recruitment process. For computer science students, we have 55 number of vacancies. So it's a great vacancy, it's a group A gazetted vacancies. So if you want to prepare for this paper, then you can join YourPedia dedicated live module. So my dear students, in this video I am going to discuss one of the previous year question that was asked in 2018. As you know, it is the if I talk about the computer science technical subject that will be asked in your main exam, and main exam this time is descriptive in nature. Fine my dear students, so you have to write your answer in step by step manner. There will be no options where you can just mark the correct options which we face general in any of the exam. Fine, here your answer is descriptive in nature. So as we already upload two videos in which I already discussed the PYQ of that exam. In this video I am just solving one more problem, that is draw the binary search tree. So we have to draw the binary search tree. Fine, binary search tree that results from inserting the key. So this is my input. Fine, that is I have to construct a binary search tree from this input in that order. Keep in mind, elements came one after another into an initially empty tree. So I have the empty tree and I want to construct a binary search tree. So first of all, you have to know what do you mean by binary search tree. So while start your answer, always give a short definition of binary search tree. If I talk about the binary search tree, first of all it is a binary tree. It is a binary tree in which if I talk about if X is any node, so I can say the parent node. If X is the parent node, then all the values, or if I talk about the left child is smaller than or equal to the parent. It means left child of this node is less than equal to the parent, and the right child, that is right child, is greater than equal to the parent. So if I talk about the basic example of BST, that is 10 to 20. So here this is my root or parent. The left child is less than 10, right child is greater than 10. One more example is here 10 is a parent, then right child of parent 20, which is greater than 10. Now 20 is parent, right child of 20 30, that is greater than parent. So in this way we can say what is binary search tree. It is basically a binary tree in which parent node is greater than or equal to the left child, but parent node is less than equal to the right child. Now we have to start our construction. How to construct the binary search tree from the given input. Fine. Suppose the first element, initially we have the empty binary search tree. Fine. Now 3 came. So step 1, let insert 3 in empty binary search tree. Empty, so no need to write short form. Why? Fine. In exam you have to write the complete full form binary search tree. So we have initially empty binary search tree. Now just insert 3. Step 2, let insert, because it is descriptive in nature, you have to write this step by step procedure. So let insert 9 in the result of step 1. In the result of step 1. So 3. Now start from the root. Start from the root of the tree. So 3. Compare 3 and 9. Compare 3 and 9 as root is 3 which is less than 9. So insert 9 to right of 3. So the result will be 3, 9. Step 3. Insert 1. Let insert 1 in the result of step 2. So 3, 9 is the input for me. Now if I want to insert 1, so first of all we have to compare, because insertion or traverse of the tree always start from the root. Then compare 3 and 1. As 1 is less than 3, so move to or insert at left of 3. So the resultant tree is 3, 9 and 1. So step 4. Let insert 7 in the result of step 3. So for the input for this step is 3, 1 and 9. Now first of all compare 3 and 7. As 3 is less than 7, move to right subtree. Find right subtree of 3. So if we go on the right subtree of 3, now again we need to compare 9 and 7. As 7 is less than 9, so insert 7 at left of 9. So my final result is 3, 1, 9 and 7. Move on the step 5. Let insert 4 to the result of step 4. Fine. So again always start from the root. So the input for this tree is this step is 3, 1, 9 and 7. That is the input. So now we have to insert 4. So first of all we need to compare 3 and 4. As 3 is less than 4, move to right subtree. Fine. So now again you have to compare. If you move on the right subtree, right now you are at 9. So compare 9 and 4. As 9 is greater than 4, so move on the left subtree. So move to left subtree of 9. So now you are at element 7. So you have to compare 7 and 4. As 7 is greater than 4, so insert 4 at left subtree of 7, or I can say left side of 7. So the final result is 3, 9, 1, 7 and 4. Now see, again it is a BST. Why? Because all the elements of the right hand side of 3 are greater than 3. Fine. Here all the elements which are less than 9 are to the left hand side. Again all the elements which are less than 7 are the left child of 7. Fine. Now we want to insert 5. I think this is step 6. Let insert 5, yes, we have to insert 5. In the result of step 5. So the input for this step is 3, 9, 7, 4 and 1. So now again start from the root. We need to compare 3 and 5, as 3 is less than 5. So I have to move on the right subtree. So next time we have to compare, you have to write each and every step. Fine, here I am not writing the fully steps. So again you have to compare 9 and 5, as 9 is greater than 5, so move on the left subtree. Now compare 7 and 5, as 7 is greater than 5, again you have to move on the left subtree. Now 4. Now compare 4 and 5, as 4 is less than 5, so insert 5 to right child of 4. So the resultant output is 3, 1, 9, 7, 4 and 5. Now I have to insert the next element is 8 and then 2. Let insert 8 in this output. Fine. So again you need to compare 3 and 8, as 3 is less than 8, move on the right subtree. Then you need to compare 9 and 8. So as 9 is greater than 8, move on the left subtree of 9. So if you go on the left subtree of 9, then you are at the 7 and 8, compare 7 and 8. So 7 is less than 8. Now 7 is less than 8, so you have to insert here. Fine. So insert 8 as right child of 7. So this is your answer. Fine. Now we have to insert the last element, that is 2. Fine. So the output of previous step is fine. If you want to insert 2, so you need to compare 3 and 2, as 3 is greater than 2, move on the left subtree. Next you need to compare 1 and 2, as 1 is less than 2, so insert 2 as a right child of 1. Fine. So you have to insert 2 here. So now check it, is it a binary search tree? Yes. See, 3 is my parent node. All the elements to the left subtree are smaller or equal to 3. All the elements which are in the right subtree are greater than or equal to 3. Move on the 1. All the elements which are less than 1 are present here in the left subtree, and all the elements which are greater than equal to 1 are on the right hand side subtree. Fine. Move on the 9. All the elements which are less than 9 or equal to 9 are to the left subtree. There is no greater element than 9. 7 elements greater than 7 are to the right subtree, less than are to the left subtree. 4 elements greater than 4 are on the right subtree. So in this way, my dear students, you have to write each and every step. Fine. No need to add unnecessary theory, just write the definition and then start your procedure. Fine. So this is one of the previous year questions from that exam. So in the upcoming videos also, we just uploading the previous year solutions. So if you want to join this exam batch, so we have dedicated live batch. Fine. So we have short span of time, so please join as early as possible. Thank you so much.